For understanding the binary to decimal conversion, let us see some basic fundamentals. What is the base of binary number system? It is 2. What is the base of decimal number system? It is 10. Why? Because in case of binary number, there are two unique symbols 0 and 1 which are called bits. In case of decimal number, there are 10 unique digits from 0 to 9. Second, what will be the input which you will be getting? You can be given a binary number, which in this case is a whole number. You can be given a fraction number, which is again a binary number. Or you can be given a mixed number, which has got both the whole number part as well as the fraction part. And you have to find out their decimal equivalent. Third important point, if it is a whole number, then this bit which lies on the extreme right, that is basically your least significant bit, and this bit on the extreme left is most significant bit. If it is a fraction number, then this bit on the extreme right is least significant bit, and this bit which lies just next to this binary point is the most significant bit. If it is a mixed number, then this bit on the extreme left right is least significant bit, and the bit on the extreme left is most significant bit. This bit will have the highest weight, this bit will have the smallest weight. So what is the concept of weight? Let us see that. So given below is the given binary number, so we will understand its weighted structure. This number is a mixed number, so this is our binary point, and the number which lies on its right side, the bits lying on the right side form the fraction portion, and the bits which lie on the left side of this binary point form the uh, whole number part. Now, regarding the weights of these numbers, let us see. For the whole number part, the weights will be, we will be writing the weights from this bit onward. That means the bit which lies immediately to the left of this binary point. For the fraction part, we'll start writing the weights from this bit onward, the bit which lies immediately to the right of the binary point. And for the whole number part, we will be writing positive powers of 2. So that powers start from 0 onward, 2 to the power of 0. And as we move towards the most significant bit, these powers will increment by 1. So let's see that. For how long should I write the powers? It will depend upon how many bits you have in your whole number part. All these are positive powers and they are increasing. What is the weight of the most significant bit? That is 2 to the power of n minus 1. What is n here? Number of bits in the whole number part. So we have 12 bits. So final weight is 2 to the power of 11 because we started from 2 to the power of 0 onward. For the fractional number, our weights are written like this, 2 to the power of minus 1, and then we will move in this direction, that is towards the least significant bit. And these powers will keep decreasing. And the weight of the least significant bit will be 2 to the power of minus m. And what is m over here? M is 5, like here in this case, number of bits in the fractional portion. If we find the decimal equivalent of these weights, we will see there exists a pattern. So 2 to the power of 0 is 1, 2, then 2 to the power of 2 is 4. So 2 to the power of 3 means 2 into 2 into 2, right? So that will give me 8. Also, you see that if you know the previous weight and you multiply 2 in it, that will also give you 4, that is 8. And if you double up 4, that will also give you 8. So any next weight is just the double of its previous weight, right? So 2 to the power of 4 will be 16, 32. Then 2 to the power of 7 will be 128. Double of 128 is 256. Then it will come out to be 512, and 2 to the power of 10 is 1024, and 2 to the power of 11 is 2048. What about the fractional numbers? So if I write 2 to the power of minus 2, it will be evaluated like this: 1 divided by 2 to the power of 2, and that is 1 by 4. So this becomes 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32. And if you find out their fractional equivalent, you will find a pattern over there of the subsequent weights. Like this is 0.5 and this is 0.25. So what is the relationship between them? Every next weight will be half of its previous weight. See, if I divide 0.5 with 2, what you get? 0.25. So that is the next weight. This will be 0.125. So if you add 0.25 twice, you are going to get 0.5. So next weight will be half of the previous weight. So this will become 0.0625 and this will become 0.03125, right? So let us understand how to use these weights in our conversion process. So there are two ways in which we can convert a given binary number to decimal. First method is sum of weights method, and second is we will multiply each of the bits with the corresponding weight, which are powers of 2, and then we will add all the resulting values. So let us take this first example, and that example is 101. This is the whole number, the binary number. We have to find out its decimal equivalent. So first we will multiply them with their corresponding weights. So 1 into 2, and you have to add up all these values. So 0 into 2 plus 1 into 2. Assign their weights, they will start from 0, 1 and 2. So this becomes 1 into 4 plus 0 into 2 plus 1 into 1. So this becomes 4 plus 0 plus 1, and that becomes 5. That is the answer in decimal equivalent. Let us use the sum of weight method. We will write all the bits, and corresponding to this bits we will write their weights. Just omit out those weights where the value is corresponding bit is 0. You have to just consider those weights where the value given value is 1. So this becomes 2 to the power of 2 plus 2 to the power of 0. That means 4 plus 1. And that answer is 5. So see, answer is same no matter whatever method you follow. So let us understand how to convert a binary fraction into its decimal equivalent. So first method is usually we will multiply it with every bit with the power corresponding weight and add them. So since this is a fraction number, so these are our weights. And this becomes 1 into 1 by 2 plus 1 into 1 by 4. So 1 by 2 plus 1 by 4, 0.5 plus 0.25, and that becomes 0.75. Clear? Now let us take another example, 0.11, and let us find out their decimal equivalent, but we will use sum of weight method. So we'll write all the bits and then we will write their weights. Because all the bits are 1, so we will add them up. This becomes 1 by 2 plus 1 by 4, 0.5 plus 0.25, and answer is 0.75. Now there is another method also which is less commonly used, but we must have an understanding of that method also. We have this number, fraction number, and we want to find out its decimal equivalent. So what we will do? First, for this fraction point, just drop this fraction number and treat 1 as a whole number. Right? I've just dropped out the decimal point, binary point, and then treat 1 as a whole number. What is this 1 in binary equivalent to in decimal? That is equivalent to value 3, right? Having found that, Now we will perform the division. The numerator will be this value 3, that is the decimal equivalent, and we will divide it with some power of 2. So what will be the power over here? Count how many bits are there in this uh, fraction portion. So it has got total 2 bits. So that 2 will become the power over here. Now this will become 3 by 4, right? And now if you calculate 3 divided by 4, this will become 4 7 the 28 and 4 5 the 20. So see, your answer is 0.75 in decimal. So see, whatever method you follow, your answer is same, right? So for the third method, what we did, we just took these 2 bits, just omit that binary point, treat it as a whole number, and find out its binary decimal equivalent. Then perform this division process. This decimal equivalent will become the numerator, and below it we will write the power of 2. What is this power equivalent to? Total number of bits in the given binary fraction. So we will just divide 3 by 4 and we get the answer 0.75. Let us take another example. You can just pause the video and you can perform your calculations. It is the whole number 111011. First, I will perform it using our sum of weight method. So we'll write all the weights. This weight will be omitted because its corresponding bit is 0. We will add all the weights where the corresponding bit is 1. So this becomes 1, 2 to the power of 1 is 2, 2 to the power of 3 is 8. Because we have omitted out certain weights in between in case there is 0. So just write these powers very carefully. Always write all these powers first so that you don't omit out any weight. So this will give me the answer 59. You can perform this way also. So it is 1 into 2 plus 1 into 2 plus 1 into 2. Remember that you write all the bits correctly. Write all the weights. So this becomes 1 into 32 plus 1 into 16 plus this thing will become 1 into 8. This thing will become 0 and this thing will become 1 into 2 plus 1 into 1. So you get 32 plus 16 plus 8 plus 2 plus 1. So you will get the answer 59 in decimal. Now let us consider this example. This will be 101, then 00011 dot 1101. So it's a mixed binary number. It has got both the whole number part and the fractional part, and we have to find out its decimal equivalent. I will be using sum of weight method. You can pause the video and you can perform your own calculations. So let us write first the whole number part and let us write down their weights. Even if the corresponding bit is 0, write the weight below it so that you don't omit out the weight in any, you don't leave out any weight in the given sequence. So we will now just add up those weights where the value is 1. So this won't be added, and this is 2 to the power of 5. These weights will be again omitted, and we will use these two weights 2 to the power of 1 plus 2 to the power of 0. So it becomes 1 plus 2. 2 to the power of 5 is basically 32. 32 plus 128. So you get the answer 163. This was for the whole number part. Now let us perform the calculation for the fraction part. So we will use sum of weight method. So we will write 2 to the power of minus 1 minus 2, minus 3, minus 4. So we'll add 2 to the power of minus 1. So we'll just add the weights where the bits are 1, and we will leave out the weight where the corresponding bit is 0. So this becomes 1 by 2, 1 by 4, and 1 by 16. And the answer you get is 0.5 plus 0.25, and this becomes 0.625. And your answer is 0.8125 in a decimal. So the final answer is 163 dot, the decimal part is 8125. Always put the decimal point at the correct location. Then another thing, let us solve this 1101 using our third method that we learned. Just for revision purpose, 1101. We will just consider this as a whole number. Just omit out that binary point, and this will be equivalent to value 13 in decimal. We'll perform now division. Numerator will be 13. Denominator is power of 2. So count how many bits are there. There are total 4 bits in the fraction part. So 4. So this becomes 13 divided by 16. Now if you perform 13 and 16, you calculate it. 16 into 8 is 128. And you get the answer 2. Then 16 1 the 16. Right? So you are left with value 4. And 16 to the 32. And you are left with remainder 8, and becomes 80. 16 into 5 is 80. So 0.8125. So if you see here, you get same answer. Right? You can subscribe the channel, share it with your friends, and we will meet again in the next video.